Good morning, students. Students, this lesson is of class 7th for the subject of physics. Topic mass and weight, which is covered in chapter 2 motion and is given on page number 19 of your physics textbook titled Concise Physics by Selena Publications. This lesson is submitted to you on 24th May 2021. Students, now first let us recall what is mass. You must have studied in your lower classes that mass of a body is defined as the quantity of matter contained in it. So what is mass? Mass of a body is defined as the quantity of matter contained in it. And children, it does not change with change in position of the body. That is, mass remains constant wherever you go. It does not change where is the position of the body. Rather, whatever is the quantity of matter contained in that body, it remains fixed. For example, if an object is having a mass of 5 kilogram on Earth, then the mass of that object on Moon or at any other place will also remain 5 kilogram. So children, what we have learned by now, mass of a body does not change with change in position of the body. It remains same irrespective of where that object moves or where that object is kept. So children, SI unit of mass is kilogram. The standard international unit of mass is kilogram. And there are other units of masses also. Smaller units of masses, you must have heard about gram and milligrams. So mass, smaller units are grams and milligrams, while you are having larger units also, which are kilogram. So children, you must be knowing that 1 kg is 1000 grams. And since we have learned in chapter 1 also that 1000 can be written as 10 raised to power 3. So we will be writing 1 gram is equal to 1 kilogram is equal to 10 raised to power 3 grams. And children, mass is a physical quantity and every physical quantity can be measured. So mass is also measured, but it is used. Which device is used to measure mass? Mass is measured by beam balance or a physical balance. So which quantity is measured by beam balance? Beam balance can measure mass of a body. So children, next comes a very usual term which we mostly used oftenly, that is weight of a body. So today let us learn what is weight. The weight of a body is the force with which Earth attracts the body. What is weight? Weight of a body is the force with which Earth attracts the body. Children, kindly pick a ball in your hand and then remove your hand from it. So take a ball, pick a ball in your hand, and then suppose this is your hand. If you place a hand of yours and then remove this hand, if you remove this, what will happen? The ball will fall down. So why the ball has fallen down? So children, it happens because the weight of the body is the force of gravity acting on it. Why so? Because what is the weight of the body? Suppose you were having a ball, the gravity was pulling the ball downward. And this force with which the ball is being pulled by earth is known as weight of the ball. So children, the ball has fallen down because the weight of a body is the force of gravity acting on it, and thus weight of the body always acts downward. Children, notice that when your weight is calculated, the weighing machine is always kept below your foot. It is never kept above your head. Why? Again, the same reason. The weight is acting downward. So your body weight is also acting towards the earth. So to calculate it, the weighing machine is always kept below your foot. Children, weight of a body changes from place to place. Unlike mass, in case of mass, it was constant, it was not changing. But children, weight of a body, it will change from place to place, and thus weight is not constant. And SI unit of weight is not kilogram, children. It is newtons. The SI unit of weight is Newton. It is not kilogram. Kilogram is the unit of mass, while Newton is the unit of weight. And weight is measured using a device known as spring balance. Spring balance is a device which is used to measure weight. Children, you can see the diagram of spring balance and beam balance in your physics textbook also. So let us study the relation between mass and weight, how mass and weight are related to each other. Children, the formula of weight is mass multiplied by acceleration due to gravity, which is represented by symbol small g. Children, the word acceleration we will study in class 8th in a very detailed manner. But for now, you just remember the value of g. The value of g will be taken as 9.8 meters per second square for Earth. In case of Earth, the acceleration due to gravity is given as 9.8 meters per second square. So children, now note that the unit of Newton per kg or Newton kg inverse are same. I have explained you this thing in your online. So students, here we have already learned that meter per second and kilometer per hour can be written as kmh minus 1. Similarly, Newton per kg can be written as Newton kg inverse. Now children, if we have an object of mass 1 kilogram, mass is 1 kg only, then to find its weight, we will say weight is mass into gravity. That is 1 multiplied by 9.8, which comes out to be 9.8 newtons. And similarly, if we are having a mass of 50 kg, so its weight will be 50 multiplied by 9.8. which comes out to be 490 newtons. Children, then we have to learn one more unit, that is kgf. This is one more unit of weight. Weight can be measured in kgf, which stands for kilogram force. And 1 kilogram force is equal to 9.8 newtons, or you can say that 1 kilogram force is equal to 10 newtons. So children, it's very easy to learn. Suppose if mass is 2 kg, then how to find down weight? Kindly pay attention. I am saying that if I am giving you mass to be 2 kg, so if we want to find weight in newtons, I'll write down the formula m multiplied by acceleration due to gravity. M is 2 and suppose g is given to be 10. So our answer comes out to be 20 newtons. This is weight on earth. The value of g is equal to 10 is weight on earth. And if I want to find weight on earth, but in the unit of kilogram force, in kgf, then what I have to do? It is very simple, children. See, m multiplied by g, m multiplied by g, and children, you write down m as 2 kilogram and g, don't write its value. No need to put the value of g. And now you can directly write down the answer in kilogram. Mass was 2 kilogram. G is acceleration due to gravity, so it becomes kgf. 2 multiplied by g is, if you don't put the value of g, the answer comes in kgf. If you put the value of g, the answer will come in newtons. Now children, do one more question. Suppose I give you mass in 5 kg. Now find the weight in newtons as well as in kilogram force. Pause the video and find the answer, children. Find weight in newton and then find weight in kgf. Firstly, put the formula. Write down the formula m into g. And now do the needful calculations. So I hope you all have done. Let's find the answer. Take mass as 5. Given to us, g take it as 10. 5 into 10, 50 Newton. While in kgf, 5 multiplied by g. We will not put the value of g. So it becomes only 5. K, G, F, kilogram force. So I hope this much is clear. Let us continue with the lecture further. So children, in the same manner, you find the answers of weight in kgf and Newton. Children, remember that weight always acts downward. If you are having a table on which we are putting a box, then what will happen? The weight of the box will be acting downwards. See, it is shown in the diagram also. There is a table on which you are placing a box and see the direction of the box. Weight of the box is shown with an arrow. That arrow is directed downward. Children, you will be amazed to know that at the center of Earth and even on artificial satellite in space, the value of acceleration due to gravity is 0. The value of g is 0 in artificial satellites and as well as at the center of Earth. So that means that weight is, what is weight? M into G. So mass into 0. Something multiplied by 0 is 0. So children, at the center of Earth and even on the artificial satellite in space, your weight, if we measure your weight, it will come out to be 0 newtons. But your mass will remain same. Mass can never be 0. It is the matter contained in a body and it cannot be 0, and it remains same whatever it was on Earth, and it will remain same wherever you go. But weight can be 0. Children, now let us study effect of change in place on mass and weight. Now if you change the place, how mass and weight changes? By now we have studied that weight depends on value of G and it changes from place to place. You know why? It happens because acceleration due to gravity changes from place to place, while mass remains same. And children, you must have heard that gravitational force of moon is 1/6 of gravitational force on Earth. What does it mean? So children, suppose we are having an object whose mass is 48 kg. What is the mass of the object? The mass of the object given to us is 48 kilogram. Then its weight on Earth will be mass multiplied by acceleration due to gravity on Earth. That is 10. So 48 multiplied by 10, 480 newtons. While weight on moon will be, since gravitational force is 1/6, that means weight on moon is 1/6 of weight on Earth. So whatever your answer was on Earth, the weight was coming 480 Newton. And children, on moon, the weight of that object will be 480 divided by 6. That is 80 Newton. Now students, mass of the object will remain same. It was 48 kg on Earth. It will remain 48 kg on moon. It will not change. But weight will change if we check on Earth and moon. So children, note 3 is important. The pull of gravity on mass of an object is G, and the value of G on Earth is 9.8 Newton per kg, which sometimes is taken to be 10 Newton per kg. So now students, after this, I have given you certain numerical as an example. So first example is a boy is of mass 50 kg. If the pull of gravity on 1 kg is 9.8 Newton, it means 9.8 per kg. And at surface of moon, it is given to be 1.6 Newton. So what are these values given, students? This is acceleration due to gravity on Earth, which is 9.8. And then acceleration due to gravity on moon is also given, that is 1.6. So children, now question is, what is the weight of the boy at Earth's surface? So what is the weight of the boy on the Earth? That is mass multiplied by G of Earth. 50 into 9.8. It comes out to be 490 Newton. And second part is mass and weight of the boy at surface of moon. So children, on the surface of moon, What will be the mass of the boy? See, mass of that boy on earth was 50 kg. So what will be the mass of mass of the boy on the moon? It will be again 50 kg. Why? Because mass remain constant. Excellent. And now let's calculate weight of the same boy on the surface of moon. So you'll write down weight of the boy on moon surface. It will be mass multiplied by acceleration due to gravity on moon, which is given to be 1.6. So if you multiply 50 and 1.6, it comes out to be 80 Newton. So I hope this is clear to you all. Go through these notes once again, students. The conversions are really very important. And then you can try the numericals of mass and weight, and then kindly do the tick marked questions of mass and weight as adjoined with the notes given to you. Even you can do the last 7th and 8th numerical also yourself. Thank you, students, and have a nice day.